The task of reverberation design is to make the room have the reverberation time and its frequency characteristics suitable for use. The work began when the shape of the hall was basically determined, and the volume and surface area could be calculated. Specific content includes the first, determine the reverberation time and its frequency characteristics suitable for use. The second, calculate the reverberation time. The third, select and arrange interior decoration materials. The reverberation time and its frequency characteristics are determined from the graph. Different halls with different usage requirements have different optimum values of reverberation time. For the same purpose hall, the larger the volume, the longer the optimum reverberation time. The figure above shows the recommended value for the optimal reverberation time that are commonly used. The figure below shows the frequency characteristics curve of the reverberation time. Find the best value of the reverberation time according to the above figure, and then use the best value as the benchmark to determine the reverberation time of each frequency in the whole frequency band in the figure below. As can be seen from the figure below, the high-frequency reverberation time should be as equal as possible to the intermediate frequency, and below the intermediate frequency can be appropriately extended as the frequency decreases, and the extent of the extension depends on the purpose of the hall. Halls dominated by music, the reverberation time is longer and the lower frequency is slightly longer than the mid-frequency. The reverberation time at 125 Hz is 1.2 to 1.5 times that at 500 Hz. Language-based halls, the reverberation time is short and the frequency characteristics curve is flat to ensure clarity. Because the area absorbs high frequencies, it is difficult to make a high-frequency reverberation time constant with the intermediate frequency. However, due to body habits, unless there are special requirements, it is not appropriate to hasten the high-frequency reverberation time to avoid unnatural feeling. The steps of reverberation calculation are: the first, find the volume V and the internal surface area S according to the designed body shape. The second, determine the optimal reverberation time and frequency characteristics according to the application requirements. The third, calculate the average sound absorption coefficient of the hall according to the calculation formula of reverberation time. The fourth, find the total sound absorption and the sound absorption of each part. The fifth, select the appropriate material and structure and determine the area so that the total sound absorption of each interface is equal to the value obtained in the first step. The reflective material are merely arranged on the walls and ceilings around the entrance. The sound-absorbing materials and structure should be arranged as far as possible in the middle and upper part of the side wall and the rear wall, and other parts that may generate echoes. Reverberation design for existing buildings should be sound-absorbing first in the rear wall, and then in the middle and rear of the side walls, and finally at the perimeter and the rear of the ceiling. This is the calculation result of the example in Chapter 11. The reverberation times of 125, 500 and 2000 Hz in a classroom are 2.1 seconds, 1.6 seconds, and 1.1 seconds, respectively. Please judge whether the room is conducive to language listening. According to the best reverberation time chart in the classroom, the best reverberation time at 500 Hz is 0.8 seconds. Since the classroom is dominated by language and intelligibility needs to be considered, the reverberation time of low frequencies should not be higher than that of mid frequencies. The frequency characteristic diagram of the optimal reverberation time should be flat. That is, the optimal reverberation time at the three frequency bands should be 0.8 seconds. Since the revolution times of the three frequencies of 2.1 seconds, 1.6 seconds, and 1.1 seconds are all higher than the optimal value of 0.8 seconds, it can be seen that the revolution time is too long and should be treated with sound absorption. Think about it. Apart from sound absorption, what other solutions are there? How to adopt to change in the number of the classrooms? Do you have the same problem in your classroom? The application of electroacoustic systems in various buildings is becoming more and more extensive, requiring architectural design to create suitable acoustic conditions for them. It mainly includes broadcasting communication system, sound reinforcement system, and playback system. The broadcasting communication system includes cable broadcasting, fire alarm, telephone, etc. Because the sending and receiving of the signal are not in the same place, there is no signal feedback problem. Because the frequency band of the signal is narrow, the fidelity requirement is not high. Sound reinforcement systems are used in space with large volumes or strong background noise. Since the signal is sent and received in the same place, there is an acoustic feedback phenomenon. That is, the sound from the speaker is received and amplified by the microphone and then sent out from the speaker, causing the sound reinforcement system to oscillate. The speaker to whistle and the sound reinforcement system cannot work normally. There is no sound feedback problem in the playback system, and the sound quality requirements are relatively high. Generally, it shares amplifying equipment and speakers with the sound reinforcement system. The generation of acoustic feedback is not only related to electroacoustic equipment, but also to indoor acoustic conditions. The microphone of the sound reinforcement system receives three parts of sound: the direct sound, the reproduced sound from the loudspeaker, and the reflected sound of the various interfaces in the room. The reproduced sound and reflected sound are the feedback sounds of the sound reinforcement system, which increase with the increase of the amplification factor of the sound reinforcement system. It is large to a certain extent, it will cause the self-excited oscillation of the system and make the loudspeaker whistle. The measures to control acoustic feedback mainly include the following aspects. The first, use the microphone close to the speaker to make the direct sound received by the microphone as loud as possible. Second, minimize the sound from the speaker to the microphone. The loudspeaker can be kept as far away from the microphone as possible. The loudspeaker with strong directivity is used to reduce the radiation to the direction of the microphone, and the directional microphone is used, and the direction with low sensitivity is directed towards the loudspeaker. Third, reduce the indoor reflected sound of the return microphone. You can take a short reverberation time or avoid strong reflections in the direction of the microphone. Use a loudspeaker with strong directivity and make its main axis point towards the auditorium. Fourth, select electroacoustic equipment with a flat frequency response curve and keep the frequency characteristic curve of the indoor reverberation time as flat as possible. The fifth, adopt a feedback controller. Placement of the loudspeaker is most closely related to the architectural treatment. The layout requirements for indoor speakers are: the first, make the sound pressure distribution in all auditoriums uniform. The second, the sound and image are constant. The third, control acoustic feedback and avoid echo interference. The arrangement of loudspeakers mainly includes centralized, decentralized, centralized, and decentralized. This diagram shows the centralized arrangement of the speakers. Arrange the loudspeaker in front of or above the auditorium, that is, on the upper or both sides of the proscenium, and the main axis of the loudspeaker needs to point to the middle and rear of the auditorium. The advantages are good sense of direction, constant sound and image, direct sound intensity, and high definition. This method is often used in places such as theaters, auditoriums, and gymnasiums. This diagram shows the distribution arrangement of the speakers. Disperse the speaker on the ceiling to distribute the sound pressure evenly. Since the listener hears the sound from the nearest speaker first, the sense of the direction is not strong, and a delay device is required to delay the sound of the nearby speaker until the direct sound arrives. Since the sound of the speaker will arrive one after another, the intelligibility will be reduced. Therefore, it is required to control the volume and directivity of the speakers. This method is suitable for halls with large area and low floor height. This diagram shows the arrangement of loudspeakers, both concentrated and distributed. Auxiliary speakers and delays are scattered on the ceiling below the balcony to ensure volume and direct sound. Due to the high position of the speakers on the upper part of the perineum, the audience close to the stage will feel like the sound comes from the top of the head, and the sense of the direction becomes poor. So the poor audio-visual speakers are arranged on the lower side of the stage or on the front edge of the stage. Distribute loudspeakers on the ceiling, set walls, and ground of the auditorium to provide the effect sound of the performance, or connect a reverberator to increase the sense of the reverberation. Electroacoustic systems require functional rooms, such as monitoring and sound reinforcement control room. You can find information on your own to learn the architectural design requirements of these functional rooms, and you can also conduct field research.